So, welcome to the tomorrow's data center session. We're delighted to have Dataiku join us. And Jerry, please introduce yourself and go. We will hold questions until the end, and I will try to give you about a 2-minute warning before your time is up at 12:15.
Okay, fantastic. Thanks very much, Ned. Hi, everyone. Great to be here. Awesome that you can join us for the session on Dataiku. My name is Jerry Hartanto. I'm what they call an AI strategist and evangelist here at Dataiku. Yeah, I don't think it's too important to talk about myself. Let's instead jump right in. And as Ned said, happy to take questions afterwards. So what we want to talk about here is AI and how it's being used in the data centers. So hopefully that's going to be of interest to you. And I will try to make this as concrete as possible. Here's what I thought we would talk about. First is how AI could be used in the data centers. What's the benefits of it? Some examples of how today it's being used. And then kind of take a step back and try to explain, here's kind of why AI works. However, kind of given that, we'll also talk about there are what we believe there are still gaps in AI's use in the data center, and how this product, which we call Dataiku, could bridge those gaps. We'll also touch on, at a very high level, some future data center trends. And then after all of that, hopefully you'll be interested enough to really kind of get to know Dataiku, and we'll do a brief introduction. All right, so what I've outlined here are kind of 3 major ways that AI can be useful in the data center. The first one is around this kind of like tailored or custom approach to understanding what's actually going on within the data center. The thinking here is that there are a lot of variables that go on there, right? You have different pieces of equipment. They are provided for by different vendors. They all have their own kind of operating parameters. They're all hooked up differently. The interactions of those hooking up is different. The cables that you use are different, etc. So, being a human, it makes it really hard to be able to look at each piece of equipment on its own. And as a result, we fall back to averages. Now, you can take that thinking and multiply it across multiple data centers. So you don't only not have one, but you've got multiple racks, and then you've got multiple data centers. And it becomes really hard to track all of that. So the point of AI, in this case, is to be able to look at each individual piece of equipment on a custom basis. So now you can do more optimized configuration, if you will, because you have a better view of that specific piece of equipment. And you can also do things like maintenance, configuration, upgrades. You can do that on a more precise basis. The second thing is you can make proactive decisions. So in most of today's world, I think we kind of react to alarms and alerts. We say, something happened, and now we got to go, take a look at that and try to fix it. With the idea of AI, it's meant to be predictive. So it's going to be looking at kind of historical trends and be able to predict, this is likely the type of thing that's going to happen, so that hopefully you have some kind of time frame to be able to react to things or be proactive, I should say, before something happens. So that potentially means lower downtime for the pieces of equipment in the data center. And then even potentially you can avoid maintenance, even though it's recommended. But if the AI tool or system believes that it's not really required right now, you could avoid those and push it off for later. And then the third thing is around efficient decision. So we kind of mentioned those alarms and alerts kind of previously. A lot of them are happening. Sometimes people figure out, well, I'm not sure if they're real alarms or alerts or not, and it becomes kind of noisy. So the idea then with AI would be to avoid chasing those false positives, and then finding those things that could be false negatives and are really problems. So let's talk about some ways that AI have been used in data centers. So one is, Google has been able to use AI in order to be able to reduce its cooling bills. In kind of the perfect world, you'd be able to go to your pieces of equipment, the pumps, the chillers, the heat exchangers, the cooling towers, etc., you'd be able to go to the knobs and you'd be able to turn those knobs based on what's actually happening if you need more cooling or less cooling. But we know that data centers are dynamic. Things are always changing in there, and it makes it hard to figure out what those optimal parameters are for three reasons. So one is that you're not only looking at, as we've mentioned, the pieces of equipment, but also the interactions of them, and also the environmental factors that may be influencing how those things react. So it becomes a pretty complex organism, if you will, and the interactions are non-linear. So it's not like you can just create an engineering equation to be able to say, hey, based on these things, this is what it should be. The second thing is if you think about all of those variables and how they change, the number of permutations is immense, if not infinite. So, being able to figure out like, oh, those things are happening, and now I'm going to go make that specific change. It just takes a while to get around to that. So you're constantly chasing the ability. You're constantly chasing yourself to make those changes quickly. And then finally, even if you're able to get it right for one data center, again, because each data center is kind of unique, you can't just port those configurations to another data center. And so what you need is this kind of like overarching method or framework, if you will, that allows you to learn from each data center and make the correct configuration changes on that specific one. So that's what Google did. Google applied its AI, and it took a whole bunch of historical information, a whole bunch of data sets, and it was able to optimize a specific metric, which they call PUE, in order to be able to say, something is about to happen, I'm going to lower or I'm going to increase the amount of cooling that I have. And you can see that chart there on the bottom. So the top is high PUE, the bottom is low PUE. When the machine learning or the AI was turned on, you could see that the PUE was lower, hence it was using up less energy. And when they turned the ML off, it pushed back up. Staying with the theme of power, we can also think about, again, that customized view and how you would get that. So if you think about a piece of equipment, let's say a power piece of equipment, the way that traditionally people have looked at it is they tried to figure out if something was operating well or not based on control charts. They would just run the equipment for a while, sometimes years, and they would look at this metric called motor amperage. If the motor amperage went above a certain level or below a certain level, they would say, something looks weird, we should go check into it, probably an indication of a problem. The problem with this approach is that if you're changing your equipment or putting a new one, you have to repeat the cycle all over again because there's such variety, as we said, in the equipment. You can't just apply one average and assume that that's going to be the same average for everything else. In addition to that, this doesn't take into account any of the environmental factors that might be influencing how that piece of equipment is working. So with an AI method, you would take a look at a whole bunch of factors. And on the right, you can see there are just a few of them. There are way more that you could take. And you can see that some of them are directly related to the pieces of equipment, but others are not. But however, they are probably influencing the behavior of that equipment. And so as a result of being able to do this, you're now able to get that kind of custom view of how that piece of equipment should operate. And you get a better understanding when it's going to be operating out of its normal, your normal specifications. Now let's take that example and extend it to a broad set of pieces of equipment. And now that you have a better understanding of, customized understanding of that equipment, we can now be proactive in nature. So again, in the past, we would rely on, what manufacturers recommend in terms of a maintenance schedule or a replacement schedule. Or you would use your intuition or your experience. You would also kind of be looking at alarms to determine when a problem occurs, but these have risk. So, the piece of equipment could fail before you expect it to fail. And also you could be doing unnecessary maintenance or replacing the equipment when in actuality, it might still be working well. So the AI method allows you to be very proactive in your approach. By looking at the different variables, you can start to get a feel for when an outage might occur, not just a second or two ahead, but potentially days ahead, which then gives you the opportunity to kind of plan for it and start to take action before it occurs. You can also do predictive maintenance. Not only do you predict, or not only can you do the maintenance before something might happen, but you could also avoid unnecessary maintenance, or what we call run to failure. And as a result of that, you'll be able to get a higher ROI out of each individual piece of equipment. And then finally, you can do predictive configuration drift. As people are making ad hoc changes to the configuration, the AI machine will be able to tell if something is going to go away from the operating parameters as a result of the different ad hoc changes, one on top of the other. Now, why does AI work? Well, it's pretty simple. So if you take a look at the data center as an example on the left, you'll see that there are a lot of things in there, not only the equipment, but also things like the type of traffic that goes through, the cables that are connecting it, the different ways that technicians operate in that data center, the different cloud providers that you're hooked up to. So there are a lot of variables that kind of go on in there. What normally would happen is someone is probably trying to take in as many of those variables as possible. They're building charts and graphs out of it. They're using their own intuition, and they're starting to make decisions as a result of that. Again, as we talked about, because there are so many of these variables, and if you take that and you multiply it across multiple data centers, you have almost like an infinite number of variables. So the idea behind AI is it's able to look at all of those variables, and not just those, but also the other location-specific variables that might influence it, all the other environmental factors. And what it does is it monitors that kind of all in some kind of real-time fashion. And it's making a recommendation to the human to say, here's what I think is happening. You might want to be taking a look at certain things. Or alternatively, you could make the AI do an auto decisioning so that the decisions are made even faster. Now, as you can see from all of this thing, there are three main reasons why AI works. So one is the breadth of data. It can take in far more variables than any human can individually. Second of all is the depth of data. It's looking at this data on a consistent basis. So the number of observations that it sees, way more than what a human can process. And finally is the speed of analysis. So the AI is obviously a machine. And as a result of that, it's able to process all of this information pretty rapid fashion and be able to make decisions on it. All right. In spite of all of this, we believe that there are still some gaps in the application of AI in the data centers. So let's call out three here. First of all, AI, what we call models, have to be maintained. So assuming that we're working with an actual AI model versus a model that a human built, which is based on rules, the way that AI models are built is that they look at previous data and they learn from that data. They learn to create their own rules from that data. Now, if that data changes appreciably, meaning in a very material way, then the model may not work as well. And so what needs to happen is that as new data is coming into the model, you need to take a look at what we call data drift. Is that data changing significantly from the data that it was trained on previously? If so, then you need to retrain the model and then to redeploy it. It's our belief that not a lot of AI that's built into machines today within the data center have that capability. So that's kind of one potential gap. The second gap is that the solutions that are in the vendor equipment are point solutions. What that means is that as new data is coming in, so for example, the environmental stuff, and as you're putting in additional sensors, as is increasingly happening, they're putting sensors into the data centers. A lot of those data is not able to be processed by the AI model within the pieces of equipment. So that's one problem. Secondly, you're not able to take an AI model, which is in one piece of equipment, and port it into another that, for example, doesn't have an AI model. It just doesn't work that way. And it may not even work very well if you were able to do that. And then finally, because the models are in individual pieces of equipment, you don't have a holistic view of what's going on within the data center. So all of those are gaps in terms of being able to make use of additional data and being able to optimize the entire data center versus just individual pieces of equipment. And then again, finally, the last thing is because of that kind of point solution, you're not able to make use of AI for the benefit of the whole data center. So you're not able to do things like capacity planning. You're not able to optimize total cost of ownership. You're not able to look across multiple business functions like marketing, sales, finance, HR, et cetera. And so these are so that's a gap as well in terms of just using the AI that's in a specific vendor solution. So the way that we would look at it from a Dataiku point of view is pretty straightforward. We would take all the data that is in the various equipment within the data center. We would pull in all the environmental data as well, and then we can pull in all the different kind of business functions in there. And with all of that, you can build multiple models that take into account all those variables. So that's kind of our solution to be able to do that. And then in terms of, I mentioned before that there are multiple business functions that could also be looked at. So from a Dataiku point of view, these are some of the problems that we've worked with in the past. So if you have kind of IT or cybersecurity issues or concerns, we've worked on that. Strategy and operations, so example, capacity planning would fall into that. Sales and marketing, if you want to do customer retention or you want to reach out to new ones, based on what you currently have set up in your data center, you could do that. Finance and accounting, manufacturing, service delivery, supply chain, for example, inventory, it can work on that. And then HR, for example, workforce planning. If you want to make sure you have the right number of technicians in there, it's able to work on that as well. So now the question becomes, how does it do it? And I apologize in advance for kind of having this complicated slide, but I'm hoping that I can walk you through it, and by the end, it all makes sense. If you look at the right-hand side, that's kind of what we're trying to get to, is to make that decision. We're trying to make those decisions better, and we're trying to make faster decisions. If you look at on the left-hand side, that's kind of what we start out with. It's just raw data stored in some place. And so now what we got to go through is the process of taking that raw data and making it into something useful so that we can make a decision. Typically, that happens by taking it through what we call this data and analytics pipeline. So what that means is you've got to get the data in, you've got to work with it, ingest it, you make sure you're connected to it, et cetera. Then you got to do this middle piece, which is basically is the biggest chunk of work, which is you're doing exploratory data analysis, meaning you're looking at it, you're trying to understand it, usually through some kind of visualization tool. You're prepping it to make sure that it's clean, that it's enriched, that you're pulling data in from multiple sources. And then you create what we call a data product, which could be like a chart, some kind of visual graphic, some dashboard, or an AI model. And then eventually you go deploy and maintain that. So after that, you go through the BI or the AI process, depending on your organization, and then you make a decision. So in theory, that works really well. Problem is that there are some problems as a result of that, from that. So one is oftentimes you just don't know where the data is. You can't get access to it. You can't get connected to it. I mean, that in some organizations is fast. In other organizations, it could take days or weeks. That middle piece of things is often done in a manual way, or you have to do some kind of coding. If you're going to code, then you need to have the right IDEs or the development environments. You have to have the right libraries put in there. And then oftentimes, you just don't have good lineage, meaning data lineage. A lot of times, people are doing this in spreadsheets. You have no idea really where the data is coming from. Really hard to follow how the data transformations are being done. That leads into people questioning the quality of it. Is it interpretable or not? And then it runs afoul of compliance from kind of a organization point of view. And then, of course, because all of that happens, there's a lot of back and forth. People are saying, hey, I need this. Can you add in that? That chart doesn't look right. And there are lots of iterations that happen there. All right, and then in the deployment part, that's often done manually. In the case of AI models, oftentimes there's recoding done because the people that deploy like to deploy differently than the people who have built it. There's a queue that develops in terms of trying to get that out, so that slows things down. And then you have to track the performance of all of this to make sure it's working correctly. So Dataiku has built capabilities or features that kind of tackle these problems. I won't go through the kind of each one individually in terms of the highlights, but I'll go through the summary. And I hope that's going to be enough to help you understand. So number one, what we have is a visual interface, which allows you to see everything end to end. And therefore, people can see exactly what's going on. In addition to that, it's self-service, so anybody can use it. We have a lot of built-in transformations, so you don't have to be a coder. You can be a clicker. Any of the things that are being built can be reused, and all of this can be done in an automated fashion. So when I mean that it's built for clickers and coders, it means that those things kind of on the right side here, these personas, all of them can use it. And then finally, there are some kind of governance or guardrails in place so that people have confidence that the tool is actually creating the type of data that people want. What does that mean? That means that individuals and teams become pretty efficient in terms of churning out those data products, which obviously means that you can now deploy more use cases, you can get additional business outcomes, and all of that generates true value. And then potentially you can even consolidate some tools depending on the type of things that you're looking to get out of the tools. Now, nothing says it more than diagrams or pictures. So pictures worth 1,000 words. And here's just some examples. So you'll see how the Dataiku kind of flow looks like. You'll see how people get the data and then they create the data products. Any particular persona can go in here and do their work at any particular point. You're able to have visibility into what people are doing. And so it's a very collaborative thing, and people can work on it simultaneously, almost like a Google Docs, if you will. Now, in order to be able to get access to these things, you can do drag and drop, and by pulling in things in, or you can just code it. And so we make notebooks available, we make the IDEs available, we make the libraries available. And then in the case of models, you can do various analysis with the data, as you can see here, which I won't go in too much into depth. And then you could also create your own dashboards and charts, all within the same platform. And again, all of this stuff that you create is reusable, and it's shareable, and everyone has visibility and transparency to it. Okay, so some future trends. So 3 things. One is we believe that there's going to be AI at the edge, and that there are going to be data centers specifically built for kind of these edge analytics. The reason for that is because people want kind of faster analytics or faster processing. And also they want to reduce the amount of data that goes into the center. So reduce the cost of that. The second thing is digital twins. Digital twins are useful for 2 reasons. One is when you put a new data center and you're trying to get that up and running, as we've mentioned, in order to use AI, it needs some kind of training data. Of course, in a new data center, you don't have that. So what you could do is you can go ahead and use the digital twin to create that training data for you. And then secondly, once a digital twin is up and running, you're able to make changes on the digital twin before making the physical changes in the data center, so that you can reduce the risk of making those changes. And then finally, the last thing is high performance computing. This is actually to help AI in the sense that as more and more people are doing cloud computing and doing AI in the cloud, HPCs will enable people to take advantage of the faster processing in order to do more AI. So we suspect that we'll see more HPCs within the data centers themselves. Okay, I think I'm running out of time here, but real quickly, Dataiku, our goal is our tagline is to do everyday AI for extraordinary people. What that means is we want to make advanced analytics available for every person within the organization. And I think based on what I've shown you, we're pretty close to being able to do that. That makes it available so that every person can become an extraordinary analyst, if you will. The way that we do that is twofold. We have a product, which I kind of just walked through, but we also have services. So if you're not familiar with the tool, obviously we have implementation solutions for that. But also, if you're not familiar in terms of AI and how to develop it, how to work on the right use cases, how to scale it, we have groups of people that are also able to help with that. Okay, I'm going to stop here just to make sure I can take questions, but I'll leave this last screen up. We're a Gartner leader, peer reviews, as well as the Magic Quadrant, and we have a lot of customers, and we also have partners.
Hey, thanks, Jerry. We do have 3 minutes left, and I'll make a general comment, which is that one of the biggest challenges that we see across all of our customers is not producing data. They've got that covered, but rather doing something actionable with it. How do they achieve value from it? How do they identify the right data to do something with? How do they keep it in the correct format? And, it's a real hurdle to overcome before people can start to use some of these more, and I think unfortunately named techniques, because artificial intelligence makes me think about lieutenant commander data, and that's not the case. We're not building, robots. We're not building the Matrix. What we're doing is allowing people to make inferences from huge data, or maybe not inferences, but whatever techniques they use. So we really appreciate that. Another thing I want to amplify is this whole notion of the edge. We're seeing more and more and more work happening, both to accumulate data at the edges where the work takes place, but also to do things with it while it's there, because of this idea of data gravity. It's so hard to move around in relative terms, and it's so easy to move the results of analysis around in relative terms. So really appreciate you raising those things. And I think the last thing is, you brought up the concept of high performance computing, and that is such a thorn in my side, because HPC means something so different to all of our customers. We have university customers where they have HPC centers, and they mean something very, very, very specific, all the way through to large enterprises that say, well, we need high performance to provide analysis, but they use different techniques and different mental approaches and different tools. So this whole space is it's evolving so rapidly that I think we're starting to see terminology collisions, and it's a really fascinating thing to me. So we didn't have any questions, and I will thank you, Jerry, for your support and for presenting. And everybody, we have in about 30 seconds, we'll start off the next session, which is Cribble. I'll see you there. And Jerry, thank you again. I hope you have a wonderful day, sir.
Thank you, Ned. Thanks, everyone.